Most people still believe the universe is calm, predictable, that objects drifting through space follow rules so steady you could carve them into stone. They think comets dim when they should dim, brighten when they should brighten, and behave exactly the way textbooks promised they would. And for the longest time, I believed that too. But that belief survived only until the night the first image of an interstellar visitor, only the third ever confirmed, appeared on NASA's public server for 19 seconds, and then vanished without a trace. 19 seconds. That was all the time the world had to see the object before it was reclaimed by the dark. Astronomers across 3 continents had been preparing for this observation. The discovery had already stirred curiosity because this object wasn't from our solar system. It came from the deep cold between stars, a place untouched by sunlight for millions, maybe billions, of years. Its arrival alone was historic. But the moment that first frame disappeared, something shifted. What should have been a routine early capture suddenly felt like the beginning of a story no one was prepared to tell. If you're listening now, you're already different from most people. You pay attention. You notice when something doesn't line up. And before we go any deeper, if this moment already feels unusual to you, share it with someone who still believes the sky behaves exactly the way they were taught. They deserve to see this too. The original image wasn't impressive in resolution, yet it carried a strange weight the moment it appeared. A faint shape drifting at the edge of the sun's light, surrounded by the weak glow of early outgassing. At first glance, nothing seemed out of place, but the frame didn't behave the way the system expected. The timestamp, a detail usually precise to milliseconds, was off by 3 full seconds. Exposure settings didn't match the instrument profile. The camera's gain values were different from the automated configuration used for tracking fast-moving interstellar bodies. These systems do not drift, they don't misfire, and a 3-second anomaly in a pipeline designed to withstand cosmic interference is not a casual error. My first instinct was to assume a processing delay. But delays don't alter exposure, they don't modify gain, they don't rewrite metadata. Someone edited something, or something forced the instrument to compensate for conditions it wasn't calibrated to handle. The object itself looked almost ordinary. A soft haze, a nucleus too faint to define, a barely visible tail. But then there was the detail most people would have missed, a subtle glow behind the coma. Not a reflection, not a lens artifact, a pale crescent of light where the background should have been completely dark, brighter than the nucleus, brighter than the coma, brighter than the source lighting it, a shadow that glowed. Comets do not produce that shape. They don't bend reflected light into a curve behind their own mass, and they certainly don't generate brightness exceeding the core in a region that should be lightless. When I saw that glow, even before the image was removed, I felt the same chill you feel when you recognize a pattern that shouldn't exist. Not because it's frightening, but because it contradicts everything you've been told is possible. Then the image vanished. One moment it was there, a raw, unedited frame. The next moment, a 404 notice replaced it. The ID hash returned no match in the archive. Cached URLs broke simultaneously. In under 20 seconds, the file was erased as if it had never been posted. If the object were just a frozen traveler from another star, why hide the first picture? Hours later, NASA released their official set of early images. Clean, processed, calibrated, all anomalies removed. No glowing crescent, no metadata inconsistencies, no unusual exposure. It was exactly what a first-pass observation should look like. Perfect, predictable, safe. Too safe. Because here's something agencies rarely admit. The first frame is always the most important. It captures the object before the algorithms correct for brightness, before smoothing filters reduce noise, before temperature compensation adjusts colors, before expectations begin shaping the data. The first frame shows what is actually there. The later ones show what the system expects to be there. And that 19-second anomaly was the only look we had at the object before sunlight began changing it, before the coma thickened, before it rotated, before the solar wind carved its shape into something more familiar and easier to explain away. I tried to convince myself I misread the glow, but I couldn't ignore the metadata. That glow wasn't compression noise. It wasn't a defect. It was part of the frame, part of the object. I spent hours digging through server mirrors, bot archives, and unindexed storage copies, hoping one of them held a ghost of the original file. Sometimes the internet forgets quickly. Sometimes it remembers in strange, fragmented ways. And somewhere in that labyrinth of residual data, a partial thumbnail surfaced. Poor quality, cropped, degraded. But enough to confirm the anomaly wasn't an illusion. The crescent glow was still there. Right behind the nucleus. Exactly where no natural light should be. It reminded me of something I once heard from an astronomer who spent his life studying faint objects. Space doesn't hide things, people do. Most people never saw that first frame. They accepted the official release, the safe explanation, the clean version of reality. But the universe never cleans itself up for our convenience. It doesn't correct its own mistakes. It reveals them if you're paying attention. And that early glow, subtle, unexpected, quickly removed, was the first sign that this visitor wasn't behaving quite like the others. It wasn't explosive. It wasn't dramatic. It was something more dangerous to certainty, a quiet, persistent contradiction. The kind that rewrites everything slowly, starting from the edges. This wasn't the last inconsistency. It wasn't even the most unusual, but it was the first moment the universe tapped lightly on the door and asked if we were finally willing to notice. Next, we follow the trail of the image NASA didn't want the world to see, the one that survived only because a machine somewhere captured its shadow. Most stories about missing data end when the file disappears. Ours began there. Because just when it seemed the first image had been swallowed by silence, a quiet post surfaced on a small astronomy forum, an amateur observer claiming they had a cached version of the vanished frame, not a screenshot, not a re-upload, a genuine autosave pulled from a secondary mirror server most people never knew existed. It appeared without fanfare, no headline, no explanation, just a short message. I think this one wasn't meant to be deleted. At first, I assumed it would be identical to whatever NASA released afterward. Low contrast, smoothed edges, a simple blob of light drifting through a star field. But the moment the file opened on my screen, I knew we were looking at something else entirely. It was sharper, much sharper, too sharp for something captured by an automated system configured to track a dim interstellar object at extreme speed. You don't get that level of detail unless the instrument was either operating at a higher precision level than the public believes exists, or unless the official version was deliberately softened. Side by side, the difference was impossible to ignore. In NASA's public release, the edges of the coma were blurred in a way that looked almost curated, like a painter brushing over harsh lines to create a safer version of the sky. The nucleus appeared faint, nearly featureless, its contours softened into something no one would question. A simple visitor, a harmless traveler. But the cached image said otherwise. The coma had texture, fine grain, sharp gradients, and in the lower quadrant, barely brighter than the background noise, something thin extended outward. At first glance, it looked like a faint scratch across the lens, the kind of straight-line imperfection that old sensors sometimes produce. But when I isolated that section and enhanced the contrast only enough to confirm its geometry, the shape became unmistakable. A second tail. Not a diffuse plume of dust. Not a thermal jet. Not a curved arc bent by the solar wind. A narrow, razor-thin line stretching away from the nucleus with a precision that bordered on unnatural, almost like a laser cutting through the darkness. The more I stared, the more out of place it looked. Natural jets widen as they travel. Dust streams curve. Ion trails bend. But this line kept its thickness, consistent across its length, unwavering, sharp even in regions of heavy noise. It was as if something was emitting a directed stream of particles in a perfectly stable path. Or something was reflecting light in a way no inert object should. If this was merely a trick of processing, why didn't NASA mention it? Why did the official version obscure it entirely? Why was the edge of the coma in their release blurred exactly where this structure appeared most clearly in the amateur file? You don't erase noise. You erase information. As I compared the two images, I found myself noticing a second, subtler detail, one you only see when you look at hundreds of astronomical frames. In NASA's version, the stars behind the object appeared softer than they should have. Their point spread patterns were smeared just enough to suggest the entire frame had been processed with a smoothing filter. But in the cached version, the background stars were pinpoint sharp. Clear diffraction spikes, no sign of artificial distortion. It wasn't just the object that was clearer. Everything was, which raises an uncomfortable possibility. The official release wasn't the raw image. It wasn't even a calibrated frame. It was a downgraded one, a version that hid information by blending it into acceptable noise. The amateur's file, on the other hand, looked like the true first capture. And that thin, unnatural tail wasn't the only unusual feature. Along its length, so faint that it only showed under specific contrast settings, were tiny breaks, evenly spaced, like pulse markers, not enough to make a claim, not enough to sound an alarm, but enough to suggest a structure, a rhythm, a signature. Another micro-reveal followed when I checked the metadata in the amateur's cached copy. There I found something the original NASA frame had tried to mask, a secondary exposure flag, a value that hinted the sensor had registered brightness in a wavelength the public documentation never acknowledged for that camera. You cannot explain that with dust, or ice, or random noise. Some anomalies announce themselves loudly, others whisper. This one merely tapped twice and asked if we were willing to look closer. And almost as if to mock the soft edges of the official NASA frame, the cached version revealed one more contradiction. The tail was pointing slightly, just slightly, in the wrong direction. It wasn't aligned with solar radiation pressure the way a dust tail should be. It wasn't perpendicular to the curve of the coma like an ion tail would be. It was deviating. Only by a few degrees, but enough to violate the basic rules of motion taught to anyone who studies celestial bodies. Even the smallest deviation is a message. You just have to be paying attention. As I sat with the image, one thought kept returning. What force could create a tail so thin, so directed, and so precise, without bending under the laws of physics that shape every other comet we've ever observed? Was it a jet? A stream of charged particles? A structural reflection? Or something we don't have a name for yet? In the next chapter, we confront that question directly. Because if this narrow tail is real, and if it truly defies the expected orientation, then the object is responding to something no one has publicly acknowledged. And that deviation might rewrite the story of this visitor in ways the later images could never hide. Most interstellar objects pass through our system like brief thoughts, silent, swift, and forgettable. They arrive on hyperbolic paths, skim the sun's influence, and slip back into the dark as if they were never here. That is the pattern. That is the rule, and for a while, it looked like this visitor would obey those rules. Its trajectory was clean. A hyperbolic arc, inbound from above the ecliptic, accelerating to more than 210,000 kilometers per hour as it fell toward the sun's gravity well. Every simulation matched. Every model predicted the same elegant curve. Nothing unusual, nothing deviant. At least not until the light betrayed it. Because when an object moves this fast, when it approaches a star with that kind of momentum, the way it reflects sunlight becomes one of the most reliable clues we have. The coma brightens in predictable gradients. Dust scatters light in distinctive patterns depending on particle size. Ion tails align under specific solar wind conditions. Everything has a direction. Everything has a reason. But the more I studied the cached image from the amateur observer, and the more I compared it with NASA's later releases, the more that thin secondary tail refused to behave like anything dictated by natural physics. It wasn't just narrow. It wasn't just sharp. It was pointing somewhere it shouldn't. To understand why that matters, you need to picture the object in motion. At 210,000 pounds per km/h, even the smallest grain of dust behaves like a sail catching the solar wind. Ionized gas flows along magnetic lines pushed outward by the sun. These angles are so well understood that entire university courses spend semesters teaching students how to read them. That's why astronomers rely on them. They don't change without cause. But the angle in the cached image was wrong. Very wrong. I overlaid the expected dust scatter model on top of the amateur's frame. The deviation wasn't subtle. Instead of bending gently away from the sun in a predictable arc, this secondary streak extended at a sharp divergence, almost perpendicular to the solar wind at that point in the object's trajectory. A direction no plume, no jet, no dust stream has any physical reason to follow. And then came the part that pushed the anomaly into something undeniably deliberate, the shadow line. In the enhanced cached frame, a faint dark filament appeared to stretch along the opposite direction of the thin tail, running toward the sun instead of away from it. Not a shadow cast by sunlight. Shadows don't behave like that in deep space. This was something else. A straight, unwavering line, so pale it almost dissolved into the noise, leaning inward, as if the object were blocking or absorbing light from a direction that contradicts its orientation. Dust doesn't do this. Ion streams don't do this. No natural comet shows a shadow line pointing toward the star that illuminates it. If light travels in straight lines, then why did this one bend around an object that shouldn't have enough mass or magnetism to cause such deflection? Nothing about the geometry aligned with the physics we trust. And that contradiction is where the trouble begins. I pulled the official images NASA released later. Frame after frame, the angle of the coma looked normal. Too normal. Clean gradients, expected asymmetry, nothing out of place. But when I matched their brightness curves against the cached file, the smoothing became obvious. Edges blurred just enough to erase the sharp divergence that defined the amateur's tail. The world was shown a simpler version of the sky. One without the angle that shouldn't exist. In the amateur image, the anomaly is undeniable. The object was scattering or emitting light in a vector inconsistent with its motion and the solar wind. In NASA's version, that vector is gone. Light doesn't lie. But people sometimes do. That thought lingered long after I closed the frames. Because if an object moving at 210,000 km/s produces a tail bending the wrong way, then either it was interacting with something we don't understand, or it wasn't behaving like a natural body at all. Whatever the cause, the next step was unavoidable. To understand the angle, I had to understand the light itself, not just its direction, but its composition. That meant digging into something far more sensitive than images, the spectral data attached to the earliest observations, the kind of data that reveals what the object is made of, what it emits, what it hides, and what it cannot be if the laws we trust still apply. Most investigations begin with images, but the truth rarely hides in what the eye can see. If something wants to slip past our attention, it won't betray itself in brightness or shape. It will reveal itself in the light it emits, absorbs, or distorts. And when the first spectral readings of the object finally became available, I realized the pictures were only the surface-level mystery. The real anomaly was written in its chemistry, and in a fleeting spike of radio energy that should not have existed. Spectral analysis is supposed to be reassuring. Carbon dust, simple molecules, predictable signatures that describe predictable objects. And at first, everything seemed normal enough. The instrument picked up CO+, a common ion in comets grazing the sun. Nothing surprising. Then came C2, the diatomic carbon that often glows a faint turquoise under solar excitation. Again, ordinary. Expected. Exactly what textbooks promise you'll see when sunlight tears. Molecular bonds apart. But then came the anomaly, one that didn't match the composition of any natural interstellar visitor. The spectrum registered NH2, but not in the faint broad bands normally produced by ammonia breakdown. This was sharper, stronger, concentrated in a way that suggested the molecule wasn't forming or decaying naturally, but being released in pulses. NH2 is fragile, fleeting, easily stripped by sunlight. Yet here it appeared with a clarity that felt engineered rather than accidental. Still, nothing in the chemical data explained what happened in the final fraction of the scan. Because in the last 0.4 seconds before the instrument glitched, right before NASA abruptly cut the public live stream, a sudden spike appeared at 1667 meters, the OH spectral line. The same frequency astronomers use to study masers in collapsing stars. The same line SETI researchers monitor for artificial amplification. A frequency that nature produces, yes, but rarely, and never in a sharp, isolated burst from a small interstellar object with no known mechanism for resonance. A spike like that doesn't whisper. It shouts. and yet it existed for less than half a second before the stream went dark. I went back to verify, replayed the spectral trace frame by frame, and there it was. A narrow, vertical flare rising above the noise floor, too precise to be random, too bright to be thermal, too short to be environmental interference. In the exact instant the spike appeared, the live stream froze. Not faded, not buffered, froze. Then the feed ended. NASA later claimed it was a telemetry issue, but telemetry issues don't synchronize themselves with specific spectral lines. They don't cut out at the exact microsecond an object emits something unusual. Coincidence is one thing. Synchronization is another. When I checked the public logs for that observing session, the story grew stranger. The automated system recorded continuous data, second-by-second entries, right up until the moment the spike occurred. Then, without explanation, a 29-minute gap appeared in the archived logs. 29 minutes. Not corrupted, not flagged. Simply missing. Motif 2. They left the timestamps, but not the observations, as if the system continued running without recording, or as if the record existed somewhere else now, somewhere not meant for the public. When I compared the missing window with the orbital timeline, those 29 minutes corresponded precisely to the period when the object rotated enough for its trailing structure to face Earth. The same structure hinted at in the cached image. The same thin tail that violated basic physics. If the spectrum truly caught a 1667 MHz burst from that region, even by chance, then whatever produced it wasn't doing so by accident. It spoke briefly, the instruments heard it, and then we were no longer allowed to listen. The official report later described the spike as instrumental noise, a phrase that has explained everything and revealed nothing for decades. But noise does not synchronize with rotation. Noise does not produce clean, narrow peaks. Noise does not vanish in the same instant a stream is cut. If it were a natural flare, some CO plus resonance, some exotic chemistry at perihelion, it should have repeated. It didn't. If it were interference from ground equipment, it should have appeared in the background logs. It didn't. If it were random noise, it should have smeared across multiple surrounding frequencies. It didn't. There is nothing more suspicious in science than a signal that appears once and never again, especially when the recording stops before anyone can verify it. Light can be bent, spectra can be smoothed, but frequency? Frequency is honest. And in that honesty lies the question no one wanted to ask out loud. Was that burst a natural byproduct of a stressed interstellar object, or was it something closer to a test? A calibration? A pulse meant to see who was listening. The next step was unavoidable. To understand whether this was nature or noise, I had to dive into the raw radio telemetry, the part that was never meant for live stream, the part hiding underneath the surface-level explanation. People like simple explanations. They like the comfort of categories. A comet is a comet. A rock is a rock. Light behaves according to charts, and signals follow equations written decades ago. But if there is one lesson I've learned watching the sky for most of my life, it's this. Nothing in the universe cares about our categories. Still, the public was told a familiar story. They were told this object, this visitor from distances we can barely imagine, was nothing more than frozen water and dust. A leftover. An afterthought of some forgotten system. And people accepted it, because it was easy to accept. But you and I have seen enough by now to question that story. Because a comet should behave like a comet, and this one didn't. From the moment it crossed into the inner system, every observation contradicted the script we're supposed to recite. Comets brighten gradually. This one brightened in steps, like someone raising a dimmer switch. Comets shift color predictably, following temperature and distance. This one changed hue as if shedding layers, revealing something deeper each week. Comets outgas in broad plumes. This one produced needle-fine jets that didn't disperse the way dust should. And then there was the OH spike, a spike as sharp as a needle, rising out of the noise with surgical precision. Comets can produce OH, yes, but not like that. Not a narrow-band pulse compressed into fractions of a second. Not timed perfectly with a rotation event. Not aligned with the exact moment a live stream cuts. Nature is messy. This wasn't messy. It was exact. The gap between what we're told is normal and what the instruments actually recorded is wider than most people realize. But once you see the pattern, you can't unsee it. First anomaly. The color changes. Green, then blue, then something closer to ultraviolet fringe. Too fast, too layered, too controlled. Second anomaly. The tail structure. One tail behaved like dust, the other like something ionized, but with a coherence that resisted solar wind dispersion. Third anomaly. The OH spike. Brief, intentional looking, and never repeated. Each anomaly on its own could be rationalized, explained away, filed under unusual but natural. But together? Together, they form a question more uncomfortable than any answer we've heard. It is like sitting in a silent forest at night, a forest you've always believed to be empty. No animals, no people, no movement but your own. And then you hear it. A knock. Soft, sharp, right behind you. You tell yourself the branch cracked by chance. You tell yourself the wind kicked up. You tell yourself whatever helps you sleep. But deep down you know. Things do not knock in empty forests, and these anomalies, they are knocks. The color shifts. The unnatural tail geometry. The microwave burst. The missing 29 minutes. One knock at a time. And the deeper I looked, the more something else became clear, something that turned this from an oddity into a revelation. If this object were truly just a shell of ice, battered for millions of years through interstellar radiation, then its outer layers should be fragile, porous, easy to fracture. But the data hints at something else entirely: the consistency of its jets, the precision of its structural shadows, the stability after perihelion. These features do not belong to a loose aggregate of frozen material. They hint at layers, at density variations, at a surface crust hardened beyond what water ice alone can achieve. That is the aha moment most people will miss. A typical comet cannot maintain these traits. Not with this level of symmetry, not with this resilience, not with this kind of spectral behavior. Whatever this object is made of, it isn't just ice. And whatever lies beneath its irradiated outer shell may not match any comet we've cataloged before. That is not a conclusion. It is not proof. It is simply a possibility, a widening of the door that official explanations keep trying to close. To test whether this is truly a physical anomaly or whether my own instincts were misleading me, I needed new eyes. Eyes beyond institutional filters. Eyes that were not required to sanitize or polish what they saw. So I turned to the observers who have always changed history first, the amateurs. The strange thing about the sky is this: when the official channels go quiet, the unofficial ones get louder. While the agencies tightened their statements, trimmed their reports, and published images that looked strangely softened around the edges, one person, just one, captured something they shouldn't have. A retired engineer in a small town in northern Spain, an old observatory dome he rebuilt with his own hands, a telescope barely the size of a child's backpack, and a photograph that changed the conversation. He didn't intend to break any story. He was simply doing what amateur astronomers have always done: watching, waiting, pointing a lens at something that felt unusual. He uploaded the image to his personal forum at 2:13 a.m. local time. No tags, no claims. Just a file name and a single line beneath it. I don't think the official image showed this. When I first opened that file, I felt something I hadn't felt in years, a tightening in the chest, a sense of reawakening. Because the moment the image loaded, one thing became clear. His photograph was sharper than the one released by NASA, and it wasn't just sharper. It showed structure. NASA's image, the one archived as the official first look, had a tail blurred into a single luminous streak. A gentle smear. Harmless. Predictable. But the Spanish amateur's photograph? It told a different story. The tail wasn't one line, it was five. 5 narrow streams of material peeling away from the core like the fingers of a hand pressed against the dark. Evenly spaced, consistent in angle. Almost intentional. Natural comets can produce multiple jets, but those jets twist, arc, diverge. Chaos is the rule. Symmetry is the exception. And symmetry on an interstellar object is something worth losing sleep over. I zoomed further. The noise cleared. The pixels aligned. And that's when I saw it. The micro-reveal that sent a shiver down my spine. Behind one of the branches, directly beneath the second tail, there was a vent, an area glowing slightly hotter than any surrounding region. Not randomly, not fading like gas. A defined point, a source, as if something under the surface had burned through the crust. A vent isn't unusual by itself, but a vent that bright, that consistent, and that precisely placed relative to the tail geometry. That is not typical. Not for any comet we've known. And here's the part that still unsettles me. The amateur didn't even notice what he had captured. He went to sleep after posting the photo, thinking it was simply a cleaner exposure. By morning, the image was everywhere, mirrored, saved, screenshotted. And only then did the agencies respond. There's a saying in astronomy circles, when amateurs see more than agencies, something's wrong. Not because amateurs are unreliable, quite the opposite. They are unfiltered, unafraid, unburdened by institutional chains, and they show what they see, even when what they see contradicts the sanitized versions the world is given. His image triggered something, a tremor through the quiet machinery of space agencies, as if someone realized the narrative had slipped out of alignment. Because within 12 hours, NASA issued a statement. A short one. Cold. Dismissive. They said the amateur's resolution must have been an artifact of overprocessing. They said multiple tails could be explained by angle distortion. They said there was nothing unusual in the coma, but if that were true, why? Did their next scheduled release suddenly vanish from the server? Why did the metadata for their previous image get updated without explanation? And why did the amateur's photograph suddenly get flagged on 2 social platforms for potential misinformation, even though it matched the raw data other observers were seeing? This wasn't the first time an outsider caught more than an insider wanted revealed. And it won't be the last. But this one moment, one photograph taken in the stillness of a Spanish night, forced a question into the light. If the sky truly is open to everyone, then why do some people act like they own the truth? This was no longer just about an object traveling at impossible speeds. It was about who gets to control the story of what enters our solar system and who doesn't. In moments like these, you expect clarity. You expect an agency built on precision, on data, on open skies and open science to step forward and steady the narrative. But when I looked for answers, all I found was silence. The first sign that something was wrong came quietly. NASA's scheduled briefing, originally set for 10 o'clock a.m. Eastern, was delayed. Not canceled, just delayed. A vague message appeared on their internal calendar. Rescheduling due to technical adjustments. Technical adjustments, a phrase broad enough to mean anything and nothing. 2 hours later, the update came again. The new start time? Pending. Another postponement, no elaboration, no explanation. The broadcast link went dark. Agencies do not delay briefings about comets. There is no geopolitical risk, no classified material, no reason to hold back. Unless, of course, what they planned to say was no longer something they wanted to say. While the world waited for the briefing that never began, something else slipped through the cracks. At 11:47 a.m., NASA posted a short message on their official Twitter feed. 6 minutes later, it was gone. Deleted, scrubbed. But 6 minutes is enough time, more than enough, for the internet to notice. The post was simple. Preliminary imaging under review. Additional artifacts detected. Artifacts, a word they rarely use publicly, and certainly not one they retract. When I dug into an archived snapshot of the post, the most unsettling part wasn't the text. It was the thumbnail. The tiny auto-generated preview attached to the tweet. A blurred image, clearly pulled from their internal media library. A moment frozen, a fragment of a frame. But even in that low-resolution thumbnail, there was something that shouldn't have been there. A shape, thin, vertical, almost like a sliver of structure jutting out from the coma. It didn't look like dust. It didn't resemble a jet. It looked deliberate. A line too clean for random nature, yet too faint to be acknowledged. By the time the tweet was deleted, the thumbnail was already circulating through private astronomer channels. People were asking the same question in different languages. What is that line? NASA's response to the growing speculation was brief, almost cold. 2 sentences emailed to journalists hours later. Images remain under review. No further comment at this time. Under review. A phrase that echoed like a locked door. No reassurances, no scientific breakdown, no charts, no graphs, no spectral notes, just a refusal wrapped in formality. And I couldn't help but wonder, if everything truly was ordinary, why did the agencies who claim transparency choose silence over clarity? Silence is not neutral. It is a decision. And in astronomy, silence from the largest institution in the world is louder than any explanation. As the United States stayed quiet, Europe moved differently. ESA had no reason to delay, no image to retract, no thumbnail to delete. Their instruments were online. Their observatories were collecting data. And if NASA wouldn't speak, then maybe another agency, one with less to protect, would. I shifted my attention across the Atlantic toward the one consortium that rarely blinks under pressure. Because when NASA hides its hand, ESA often shows theirs. And the next data feed coming out of Europe was about to break the quiet wide open. When one door closes, another monitor lights up. While NASA hesitated behind carefully worded silence, Europe did what Europe often does in times like this. It kept observing. ESA doesn't have the same media gravity. It doesn't dominate headlines in the same way. And perhaps because of that, its data sometimes slips past the filters that catch everything else. This time, a small oversight, or perhaps just a delay in censorship, let something important escape. Late that night, ESA released a short sequence of images, 3 frames taken minutes apart, tracking the object as it approached a critical region of its path. No fanfare, no press conference, just a quiet upload to a public archive and a technical note about ongoing photometric analysis. To most people, they were just 3 more dots in a sky already full of dots. But to anyone paying attention, they were a crack in the wall. The frames were tagged. Frame 1, Frame 2, Frame 3. Each one showed the object tightening its curve toward the sun, the coma swelling as the energy pouring into it increased. At first glance, everything looked as you'd expect, a brightening core, a growing tail, a standard cometary response to rising solar radiation. But the moment I looked at the timestamps, the pattern broke. Frame 1, 22/17/03 UTC. Frame 2, 22/17/09 UTC. Frame 3, 22/17/15 UTC. 6-second intervals, except there was something off. The star field behind the object did not shift the way it should have between Frame 1 and Frame 2. It was subtle, but it was there. Parallax, object motion, background drift, none of it matched perfectly with the reported time gap. The timestamp for Frame 2 was wrong, by perhaps 1 or 2 seconds, maybe more. It had either been mislabeled or altered. In deep space, imaging, seconds are not trivial. At more than 200,000 kilometers per hour, this object was covering nearly 60 kilometers every single second. Shift a timestamp, and you don't just misplace a dot, you distort its entire trajectory. Still, even more troubling than the timing was the color. In Frame 1, the object glowed a weak green, consistent with the C2 signature we had already seen, that familiar ghostly hue of molecular carbon fluorescing under sunlight. In Frame 3, the green was clearly deepening, edging toward a turquoise tinged with blue, hinting at ionization and high-energy excitation. But Frame 2 didn't quite match either side. Its core was brighter, not just relatively, but disproportionately. The central region flared with a whiteness that pushed beyond the simple transition from green to blue, like an overexposed lamp shoved into a color that had not yet decided what it wanted to be, and yet the surrounding coma didn't expand to match that jump in brightness. The outer layers stayed muted, as if the light had surged from within but hadn't yet had time to diffuse outward. Sunlight doesn't do that. It warms gradually. It excites progressively. It doesn't selectively amplify the center while leaving the edges lagging behind. In the raw color channels, the inconsistency was even more obvious. The green component rose modestly. The blue spiked sharply. The red barely moved. That kind of response suggests a focused event, not a slow, even warming. A sudden injection of energy, not a gentle glow. And then came the micro-reveal that turned a curiosity into a warning. When I measured the brightness curve over the 3 frames, something stood out. In a natural scenario, the tail should widen as brightness increases, like breath fogging more heavily in cold air. But here, the increase in core brightness occurred before the tail expanded. In frame 2, the nucleus went bright, far too bright for a body still that far from the sun. The tail, however, remained almost the same width it had in frame 1. Only in frame 3 did it finally flare outward, catching up to the surge that had already happened. In other words, the object brightened first. The tail responded later. That sequence is wrong. It's like watching a match head glow intensely for a moment before the flame appears. Light leading the fire, not following it. Sunlight can't accelerate brightness like that, not in a way that leaves the outer coma lagging behind. Not in a way that compresses the spike into such a narrow window between frames. Not without some additional source of energy coming from within or from a directed interaction. I checked ESA's notes to see if anyone had commented on this. All I found were short lines in the observation logs. Flux anomaly in second capture, under verification. Instrument check triggered after frame 2, instrument check. There's that phrase again. Blaming the lens instead of the light. But if the instrument were malfunctioning in frame 2, why did the background stars remain perfectly calibrated? Why did the field geometry remain consistent? Why did only the object misbehave? Mistakes rarely isolate themselves so politely. By the time others began downloading the frames, ESA had quietly replaced the original archive entry with a new bundle. The images were still numbered 1, 2, and 3. The content was nearly identical. But the color balance had been adjusted. The spike in frame 2 had softened, the brightness curve had been smoothed, the timing error remained. But the light had been tamed. Only those who captured the first version saw the wild surge hidden in that middle image. Only those who downloaded early realized there had been a moment of raw, uncontrolled brightness, an internal flare that no later correction could truly erase. It is tempting to believe this was all innocent. A calibration issue. An overlooked gain misconfiguration, a routine post-processing fix. But at some point, you have to ask, why do these fixes always seem to move the data closer to what we expect and further away from what we actually saw? The angle of the tail, the 0.4 second OH spike, the missing 29 minutes, and now a frame where the core brightens before the tail. Filed under instrument review and quietly replaced. Piece by piece, the story is drifting away from the neat, comfortable label of just a comet. The next clue would not come from images at all. It would rise from a different kind of observation, waves stretching across the radio spectrum, captured by an array in the southern hemisphere that listens to the sky in a frequency most people never think about. It was time to follow the signal south, to a desert in South Africa where a network of dishes known as Meerkat was about to add its voice to the growing list of inconsistencies. Most people watch the sky with their eyes, a few with their telescopes. But the rarest observers, the ones who hear more than they see, listen in frequencies where silence should be absolute. Frequencies where only chemistry, plasma, and cosmic dust have anything to say. And that is where the next anomaly surfaced. When ESA's frames left too many questions unanswered, I turned toward the southern hemisphere, to a patch of dry earth in the Karoo Desert. There, arranged like a frozen field of metal flowers, stands Meerkat, one of the most sensitive radio arrays humanity has ever built. It listens at frequencies where comets whisper their chemical signatures into the void. One of those frequencies is the OH line at 1667 MHz. A classic indicator of water molecules being broken apart by sunlight. A mundane, natural phenomenon, which is why what happened next shouldn't have happened at all. Meerkat logged 2 OH bursts within a 47-minute window. Not one. 2. On paper, this shouldn't be remarkable, but the shape of those bursts, their razor-edged profiles, was nothing like the broad, fuzzy signatures expected from a diffuse cloud of gas. Natural OH emissions behave like smoke signals in the wind. They drift, they widen, they smear. But these pulses were narrow, too narrow. Their edges rose sharply, as if cut from the noise with a blade. The array's internal report actually used a phrase I haven't seen associated with any comet before. Uncharacteristically non-Gaussian. Translated? It shouldn't look like this. The first burst lasted less than half a second. The second, slightly longer, 0.7 seconds, but identical in shape. Almost like a pattern. Almost like an attempt at rhythm. Except comets don't keep rhythm. I overlaid the 2 bursts and something else appeared, something that made my stomach tighten. The pulses did not just look similar. They aligned in a way that pointed toward the rotation of the object itself. The estimated rotational period, calculated from earlier jet modulation, was roughly 5.3 hours. When I divided the 47-minute gap by that period, the ratio wasn't random. It fell into a precise phase angle, one that corresponded to a specific orientation of the nucleus. In other words, the pulses arrived when the same face of the object turned toward Earth. Natural emissions don't synchronize with spin phases. Not this cleanly, not this predictably, unless there was some vent, some exposure, some surface feature rotating into alignment twice within a single observation window, and that would be odd enough. But something in the spectral curve hinted at more than a surface vent. The bursts weren't symmetrical. The rise was faster than the fall. A sharp ascent, then a gradual decay. Like a heartbeat quickened by an unseen stimulus, and yet all public commentary from observing teams framed it as likely natural. That phrase again, likely, as if they were convincing themselves as much as the world. Still, no one wanted to discuss why the amplitude of the pulses differed by less than 2%, or why the onset times aligned with mechanical precision, or why the second pulse arrived with the exact instrumental delay, compensation already applied, before processing. Someone, somewhere, had expected the second pulse. I reached out to 2 researchers who occasionally share off-the-record insights, the kind of people who whisper the truth in private but would never say it into a microphone. One wrote back only a single line: "If these pulses came from a diffuse coma, I'll quit radio astronomy." The other replied with something even stranger: "Check the subharmonics. It's not clean noise." But the most unsettling part was not the bursts themselves. It was the way the official logs dealt with them. The automated report flagged them as high-confidence detections. Then, 8 hours later, a second version of the report was uploaded, altering the description to uncertain and shifting the gain correction parameters, edits after the fact. Corrections that only softened the anomaly instead of explaining it, as if the data were being massaged into normalcy. I've said it before, and I'll say it again. Nature doesn't edit its own fingerprints. People do. The rotation-aligned pulses, the unnatural sharpness, the attempted retroactive smoothing, all of it pointed to an object whose behavior was not consistent with the frozen relic we were told it was. The only logical next step was to analyze the rotation pattern itself. Because if the light, the color, the tail structure, and now the radio pulses all sync with the same rotational phase, then this object is sending a message we haven't learned to read yet. And the place to begin understanding that message lies in the mathematics of its spin. Rotation should be the simplest thing in the universe. A body spins. It keeps spinning. Unless something strikes it, warms it, or tears it apart, its momentum remains nearly unchanged for centuries. But this object, it rotated like something alive. The early estimates put its rotational period at 5.3 hours, derived from the gentle pulsing of its brightness, the rhythmic modulation of its jets, and the fluctuating shadows inside its coma. A solid, dependable number, the kind of number you build models around, except the models broke almost immediately. The first sign came from a string of amateur photometric logs from Spain, Chile, and New Zealand. Observers across 3 continents recorded an irregularity, small at first, then undeniable. The light curve didn't just shift, it tilted. As if the object had briefly altered its own balance, redistributing weight in a way no natural comet nucleus should be capable of. For 12 minutes, just 12, the rotational signature warped. The phase drifted. The amplitude changed. The brightness peaks stretched farther apart. It was as if the object had suddenly become heavier on one side, lighter on the other, then returned to normal. That suggests a moment of inertia change, which suggests internal motion, and comets do not rearrange themselves from the inside. No natural outgassing event, no surface fracture, no thermal stress can explain such a fast and temporary change. Those processes are violent, messy, permanent. They don't reset. But here, in that narrow 12-minute window, the rotation altered and snapped back. To confirm it, I took a deeper look at the tail. Not the primary plume, the one everyone sees, but the finer structures embedded within it. Dust, ions, carbon monoxide ribbons, all of it dances to rotational harmonics when a body spins. And what I found made the radio pulses look tame. Every 5.3 hours, the tail didn't just wobble, it changed shape. 3 times, exactly 3. Same pattern, same timing, same sequence. Tail wide, tail split, tail sharply narrowed, then the cycle restarted. No drift, no chaos, no randomness. I aligned the rotation phase markers with the meerkat pulse data. The fit was uncomfortably precise. At phase angle 0 degrees, the moment the same face aligned. With Earth, the tail contracted into a needle. At 120 degrees, it widened. At 240 degrees, a secondary plume emerged like a twisting blade. Then, back to the start. 3 transformations, every full rotation. Like clockwork, like program. By now, there was no way to pretend this was just another icy rock tumbling through space. Even NASA's own models had begun to diverge. Their predicted trajectory, published 5 days earlier, no longer matched the new position estimates. Their margin increases were subtle, half a degree here, a fraction of a percent there. But for an object moving at 210,000 kilometers per hour, tiny deviations meant massive forces were acting on it. And the timing couldn't have been worse, because with every hour that passed, the visitor was getting closer to the sun, closer to perihelion. Closer to the region where heat fractures the weak, tears apart the fragile, and reveals whatever lies beneath the surface. Most comets break when they approach that furnace. Some fade. Some disintegrate into vapor and dust, never to be seen again. But objects with internal structure, objects that behave as if something inside can shift, they survive. They endure heat in ways we don't fully understand. And as I watched the spin cycle align with the pulse cycle, and the tail transformations click into place like gears in a hidden machine, I realized the next stage of this journey would expose one of 2 truths. Either this was the most resilient natural body we had ever encountered, or it was something else entirely. Ahead lay the sun, the crucible, the test, perihelion inbound. There comes a moment in every object's passage through the inner system when it meets something no calculation can soften, no prediction can fully contain. A boundary older than our instruments, older than our species. A place where fragile visitors either reveal their true nature or are erased. For this traveler, that moment had a date. October 29th, perihelion, the threshold of the sun. As the days narrowed toward that point, the object's behavior grew stranger. Not in chaos, but in intensity, as if every kilometer closer to the solar furnace peeled away one more layer of disguise. The first sign came in its color. We had all grown accustomed to the soft green glow, the telltale signature of diatomic carbon. We had watched it deepen, watched it transition, watched hints of blue creep into the coma like bruises rising beneath the surface. But nothing prepared us for what happened next. Within 48 hours of perihelion, the green vanished. In its place rose a piercing blue, Not the gentle hue of scattered ions, but the electric violent blue of extreme ionization, CO+ under high-energy bombardment, a color that only appears when solar wind slams into material with enough force to strip electrons clean off atoms in a single blow. Objects do not normally turn that shade at this distance. They require more heat, more exposure, more time. But this one responded instantly, like a surface already primed for transformation. Even the ESA feed struggled to calibrate the new intensity. Automated correction scripts failed, color channels flattened, and several stations marked the object as beyond expected excitation. Sunlight alone doesn't cause that. Not that fast, not that deep. As the color intensified, the plasma environment around the object began to show stress. That's the word one researcher used in a private IRC channel, stress, as if the electrified gas around the nucleus were tightening, collapsing, coiling around something hidden inside. And then, for the first time since the 1667 MHz burst, the plasma wave monitors registered a spike. It showed up on NOAA's solar wind charts first, a thin line, a jump, sharp, defined, barely half a second long, but unmistakable. A spike that synchronized once again with the object's rotation angle, and just beneath that spike lay a faint oscillation, so quiet it nearly drowned in the noise. A tremor in the solar wind. A kind of shadow pulse rising from the object's immediate environment. Plasma doesn't do that on its own. Not without a trigger. Not without something interacting with the stream. Imagine tossing a stone into a river and seeing the water ripple upward instead of outward. That was the anomaly. Something wasn't just reacting to the sun, it was responding. But as the plasma spike spread through the monitoring systems, something else happened. Something that had been inevitable yet still felt surreal. The object began slipping toward the sun's glare. Frame by frame, pixel by pixel. Its luminous body drifting into the blinding wall of scattered light until the sensors could no longer separate it from the star behind it. Every hour, the glow thinned. Every hour, the vectors shifted. Every hour, the tracking software threw more warnings. And then, just past midnight UTC, the predictions converged. The variable lines peeled into one. It was going to disappear, not in the poetic sense, not metaphorically, literally, behind the sun, into a region where no ground-based telescope could follow. This was the threshold, the moment every dataset fears. The vanish point, solar conjunction. For the next 48 hours, we would be blind, cut off, dependent only on deep space probes and whatever images the agencies chose to release. If they released any at all, and as the final pre-vanish frames streamed in, bluer, hotter, sharper, I couldn't shake a single thought. Objects don't change this much in the last hours before entering a star's shadow unless something is forcing them to. Whatever was happening inside that nucleus, we were about to lose sight of it right when the truth was close enough to touch. There are times when the sky goes quiet in a way that feels unnatural. Not peaceful, not serene, but emptied. Like something has been removed, not merely hidden. That was the feeling the moment the object slipped behind the sun. Every observatory, every solar probe, every automated sky monitor waiting for some lingering fragment, all of them saw the same thing. Nothing. A blank field. A silence carved into the center of our instruments. For 7 hours, the visitor was gone. No infrared trace, no ion tail scatter, no coronal glint, not even the faintest echo in plasma densities. Just absence. And that absence was its own kind of anomaly, because even during solar conjunction, most comets leave something behind. A trailing haze, a delayed diffraction ripple, an arching tail that bends through the corona's influence. But here, the transparency was total. As if the object didn't pass behind the sun, but passed out of the frame of reality itself. The agencies responded with expected language. Interference. Solar scatter. Detector saturation. Words meant to place blame on the instrument, never on the phenomenon, but when I sifted through the raw logs, one detail refused to align with the rest. At 04:19:32 UTC, a heliospheric imager flagged a position error. Small at first glance, just 14 arcseconds off predicted alignment. The kind of number you could dismiss if you wanted to, but 14 arcseconds at this distance isn't drift. It's movement. That means the last known coordinate of the object didn't match the path every major model had projected. Not NASA's, not ESA's, not even the independent physics-driven simulations published by amateur groups. All of them agreed on where it should have been. None of them matched where it actually was. Either the tracking software failed in only a single instrument, unlikely given the precision of the device, or the object shifted course in the final moments before disappearing. And then came the last frame. The last true piece of visual evidence before the 7-hour void. It was captured by a coronagraph camera, one of those instruments designed to blot out the sun so that faint structures in the surrounding space can be revealed. In most cases, such frames are dull, static noise, dust streaks, corrupted pixels. But this one was different. The object, just seconds from vanishing, flared. A sharp, narrow burst of light, too white to be dust, too fast to be solar scatter. It didn't bloom outward like gas. It snapped. A brief, tight flash like the discharge of an electric arc across metal. A signature that didn't belong in vacuum. A glow that sketched the outline of the nucleus for a fraction of a second, then folded into the background. It looked less like a flare and more like a reaction, a mechanical response to pressure, a structural adjustment, a final pulse before the sun swallowed it from our view. The instrument's report described it as an uncharacteristically linear excitation event. Linear. Not diffuse, not noisy, not comet-like, but that frame never reappeared in NASA's public archive. It was replaced by a slightly dimmer version, same timestamp, same label, but lacking that arc-like flash. The original survived only in the logs of a European researcher who downloaded it before the replacement went live. Objects don't disappear. Data does. Someone decided which version of the sky we were allowed to see. For 7 hours, nothing came through. No official mentions, no radio bursts, no emergency updates, just a gap, a perfect absence in the midst of chaos. And there is something to be said about those hours. How humanity stared at a blank region of space where something transformative had just passed. How astronomers checked their feeds over and over, hoping for a glint. How even the agencies seemed to wait, uncomfortably, for what might return on the other side. Because the vanish was never the real mystery. The real mystery was this: what shape would the object have when it reemerged, and whether it would come out looking like the comet everyone claimed it was, or something changed by the furnace of the sun. There is a moment, just after the darkest stretch of a long night, when something returns to sight sooner than it should. It is not a sunrise, nor a predictable alignment, but an interruption, a re-entry. A presence stepping back into the frame before the world is ready for it. That is how the object returned. Not gradually, not with the soft swelling glow of a comet easing out from behind the sun, but suddenly, as if it had been waiting there, in the glare, choosing the moment to be seen again. At 11:31 UTC, one of ESA's heliocentric monitors captured it first, a sharp white-blue point emerging from the solar scatter, not green, not turquoise, not the deep ionized blue that had consumed it before the vanish. This was white-blue, an almost metallic glow, cold and luminous, closer to the color of arc-welded steel than any comet we've ever known. Natural objects do not come back from behind the sun looking younger, brighter, tighter in form. They usually emerge ragged, their tails blown apart, their comey thinned, their cores fractured by thermal stress. But this one looked refined. The first anomaly came immediately. Its position. The reappearance did not match the ephemeris. Not NASA's, not ESA's, not the independent models. Every trajectory had predicted a smooth outbound curve, yet the object appeared 4 arc-seconds off its expected path, a deviation small to the naked eye but enormous at interplanetary distance. 4 arc-seconds at this range means a positional shift of tens of thousands of kilometers. A correction, a nudge, a force unaccounted for. Some will blame asymmetric outgassing. Some will say the coma pushed it slightly off course. But outgassing does not create instantaneous clean adjustments. It jerks, it sputters, it leaves visible scars in the tail, This shift had none of that. It was precise. And then came the moment that silenced even the skeptics. As more frames streamed in, the bright new coma sharpened, revealing a thin, pale structure extending toward the sun. Not away from it, toward it. An anti-tail. A phenomenon rare enough, but for this object, at this moment, impossible to brush aside. Anti-tails form from large, heavy particles that refuse to bow to radiation pressure, remaining pinned to the inbound orbital plane. But here, the geometry didn't line up. The orientation didn't match the predicted dust sheet. The angle was wrong. The timing was wrong. And the density of the line was too defined, as if made of material heavier or more cohesive than simple dust. I magnified the incoming ESA frames, pixel by pixel, mapping the brightness gradient through the anti-tail. The result should have been diffuse. A fading smudge. A low-density extension. Instead, it formed a narrow, coherent strand, thin as a filament, straight as a drawn line. No smearing, no curvature, no drift. At its brightest point, the anti-tail intersected the object's new limb angle at a perfect sliver of symmetry. This was not a random scattering of debris. It was a signature, a structural echo. And the brightness profile of the anti-tail revealed a micro-reveal that had gone unnoticed in the first few minutes of analysis. The strand brightened before the forward-facing coma did. A backward flash, a tail that reacted in advance of the front. Light traveling the wrong direction. Natural bodies do not behave like that. Not without internal alignment changes, not without some deeper reorganization, a rearrangement of material under the surface before external structures respond. It looked in some subtle way as if the object had turned itself outward from within. The sun's furnace had done something to it, or awakened something in it, or stripped away a layer we were not meant to see. The 7 hours of silence had passed, but the feeling of absence lingered. Not because the object vanished, but because it returned as something altered, as though the sun had carved away its mask. And as the first amateur observers began pointing their telescopes toward its new trajectory, they realized that the object's entire surface now glowed with a sheen that hadn't been there before. A hardness, a smoothness, a brightness that defied the expectations of any natural crust. The question was no longer whether it survived perihelion. It was what form it survived in, and whether the sun revealed a truth the agencies had never prepared us to face. Most objects that wander through interstellar space for millions, perhaps billions of years, arrive here softened. Weathered, their surfaces battered into fragile powder by cosmic rays that never stop carving, breaking, eroding. But when the object reappeared after perihelion, its surface didn't look weakened. It looked reinforced. Data from multiple observatories suggested something extraordinary, a hardened outer shell, nearly 20 meters thick, formed not by gentle processes, but by relentless atomic violence. Cosmic rays, over unimaginable stretches of time, don't simply chip away at surface ice. They remake it. They rearrange its molecules. They weld layers together under pressureless cold, forming a crust denser and more durable than anything natural comets typically retain. That alone would be remarkable. But what truly unsettled me was the way the crust behaved under intense solar heating. A typical comet approaching perihelion sheds its softened layers like old skin. Dust erupts. Jets explode from fracturing pockets. The surface becomes chaos. But this object, instead of shedding material, seemed to hold together. Spectral readings taken within hours of its reappearance revealed reflections too sharp, too coherent, too uniform for radiation-processed organics. The albedo spike didn't match carbon compounds, or silicates, or even the exotic ices expected from deep interstellar origins. Its reflectivity pattern looked foreign, tight, smooth, almost metallic in specific bands, but not quite metal. Not any metal we know. Whatever the crust truly was, it wasn't merely ice cooked by cosmic rays. It was something that had learned to withstand them. And then came the anomaly we couldn't pretend to ignore. Across several independent datasets, from Chile, from Italy, from Australia, a faint but unmistakable feature appeared. A fracture. A thin, arch-like line running across the surface, visible only in the frames captured immediately after perihelion. It wasn't random. It wasn't ragged. It wasn't a typical thermal crack. It was segmented, like a seam, not a break caused by heat, but a boundary revealed by it. It ran along the nucleus in a way that seemed almost structural, curving with the object's rotation, becoming visible only when illuminated from a precise angle. And no matter how many times the agencies corrected their releases, that seam returned, always faint, always on the edge of erasure, always threatening to rewrite what we thought we knew. One European spectroscopist described it privately as a fault line beneath a shell. Another called it a doorway that never fully opens. And an amateur in Japan simply wrote, "If that's a crack, something is under it." The more I examined the high-resolution frames, the more disturbing the implication became. Perihelion hadn't destroyed the crust at all. It had activated it, softened it, revealed it, which meant the sun had not killed the object. It had peeled back one layer to reveal the truth of another. But if the outer crust had been breached, even slightly, that meant pressure inside the object might now be finding new paths outward. New vents, new emissions, new anomalies waiting to erupt. And so the next step was unavoidable. If the crust cracked, even in a single place, then something beneath it was preparing to speak. When an object survives a pass near the sun, its surface is supposed to look exhausted, softer, scattered, a battlefield of fractures and collapsing layers. But this one, it didn't collapse. It awakened. The first sign came in the form of a light, a pinpoint glow. On the mid-latitude region of the nucleus, so small it could have been dismissed as noise, so faint it could have been mistaken for a pixel artifact. But it wasn't noise, and it wasn't a glitch, because the glow kept returning. The vent, if that's what it truly was, did not exist in any pre-perihelion image. Dozens of archives, dozens of observers, NASA, ESA, amateurs across the world, none recorded such a feature. But now, in the first 48 hours after reappearance, there it was, a sharp, focused point of brightness that refused to behave like a natural jet. Natural vents erupt chaotically. Irregular bursts, no discipline, no rhythm. But this one brightened in a cycle, a clean, repeating cycle. Every 17 minutes the intensity rose, slow at first, then steep. Peaking in a flare before fading again, only to restart the pulse. 17 minutes, not 16, not 18, not fluctuating with thermal spikes or solar turbulence. A fixed period, too disciplined for chaos, too organized for ice. When I charted the exact timing, the curve took shape like something alive, a slow inhale of light, a sharp exhale of energy. Even the agencies couldn't control this one. NASA's automated flagging system marked it as possible rotational hotspot. ESA called it localized albedo anomaly. Neither term explained the periodicity, because rotation didn't match 17 minutes, surface shedding didn't match 17 minutes, thermal stress fractures didn't match 17 minutes, something else did. Internal cycles, processes that originate beneath the crust, not on top of it. And then came the micro-reveal, a detail small enough to hide in the noise, but impossible to forget once you noticed. During each brightness peak, the spectrum shifted. Not dramatically, just enough to betray the presence of fresh material, being exposed to sunlight for the first time. Material that hadn't touched space in millions, maybe billions of years. Material that still carried the chemistry of another star system. Unaltered by cosmic rays, unbleached by solar wind, untouched until now. It was as though the perihelion crack we saw earlier had opened just enough for something under the shell to breathe outward, to release, to announce itself. Something beneath the shell wanted to be seen. I don't say that lightly. I don't rush to mystical language or sensational claims. But the periodicity, the brightness profile, the spectral shift, all of it pointed to a vent that was not a byproduct of surface chaos, but a sign of internal structure responding to solar stress, and not randomly, not explosively, but with purpose, predictable, repeatable, timed. The amateurs noticed it first, a handful of faint peaks in the photometry logs, and once the pattern emerged, they aimed their cameras again, their scopes tracking a point of light that pulsed like a heartbeat. Because if the agencies preferred to soften the data, the amateurs were about to sharpen it. There is a rhythm to these stories, not in the sky, but on the ground. Whenever the agencies hesitate, whenever an image appears too polished, too softened, too carefully cleaned, a different kind of eye steps forward. Not an institution, not a mission team, just a backyard observer with a telescope, a cooling fan, and patience strong enough to wrestle meaning from darkness. And once again, they saw what the agencies didn't show. The first amateur capture came from a hillside in northern Italy, a 6-second exposure taken under thin clouds. At first glance, it looked ordinary, the glowing nucleus, the familiar surrounding haze. But then the shape emerged, a contour around the object that didn't belong. Not spherical, not oblong, not the uneven, frayed silhouette of a natural body. It appeared sculpted. Not smooth, but patterned, as if the surface reflected light in a geometry inconsistent with dust or ice. The amateur who captured it wrote only one thing in his notes: shape feels wrong. And he wasn't the only one. Across forums in Spain, Brazil, Japan, Chile, and Australia, nearly identical captures appeared over the course of 12 hours, each revealing something the agencies either didn't notice or didn't announce. Because while NASA's official frame for the same timestamp looked washed, blurred on the edges, faded around the limb, the amateur versions were razor sharp. Motif 5 returned, the blurry official picture, the clear amateur one. Every time this pattern appears, it whispers a single uncomfortable idea. When amateurs see more than agencies, someone is choosing what the world gets to see. But the shape wasn't the only anomaly. Something even stranger was unfolding behind the nucleus. The tail, once chaotic, sometimes forked, had warped into a curve that shouldn't exist in a natural comet. A long, slender arc bending outward in a pattern that resembled not a dust plume, not an ion jet, but a hyperbolic sweep, a curve too clean, too mathematically tight for random particle flow. The direction didn't match solar wind pressure. The density gradient didn't match water ice jetting. The arc bent as though responding to an invisible field, one amateurs could not measure but could certainly see the imprint of. A hyperbolic tail in space often means influence, not of the sun but of the object itself, as if something about its rotation or internal structure was carving the environment around it. But the most disturbing detail came in one photograph, a single 6-second exposure from a Japanese observer. Amid the smooth, hyperbolic sweep of the tail lay a streak. Not curved, not diffused, a perfectly straight line running across the coma like a cut from a blade. Straight lines in space images can mean many things: satellites, cosmic rays, even CCD noise. But this one didn't match any of those. Its angle was wrong for a satellite track. Its length didn't match cosmic ray strikes. Its consistency remained uniform rather than tapering as electronic artifacts do. It appeared behind the nucleus glow, not over it, which meant it wasn't noise added by the sensor. It was a feature recorded in reality, a straight, narrow streak in the halo of a comet-like object that should have no straight features at all. That single detail, that 6-second reveal, was enough to send amateur groups scrambling to isolate the shape, map the angles, trace the hyperbolic curve, and determine the origin of the streak. NASA's corresponding release for that same moment softened again. Edges blurred, tail diffused, the streak missing, not faint, missing. And every time amateurs do what agencies won't, the question grows louder. If the sky is the same for everyone, why did the institutions with the best instruments show the least? The new vent, the crust seam, the anti-tail, the misplaced reappearance, the hardened shell, all of it pointed toward one unavoidable conclusion. The object's trajectory had changed again. Subtly, silently. In a direction the predictions did not expect. And if the tail shape was any indication, the force behind that change was not coming from outside, but from within. It was time to re-examine the mathematics, the vectors, the thrust-like offsets hiding in the data the agencies preferred not to mention. Because if the orbit had shifted, even slightly, it meant the sky was no longer following the rules. There are trajectories in the solar system that feel familiar: soft ellipses, wide parabolas, the gentle arcs of wandering ice. Patterns shaped by gravity, dust, heat, and time. The quiet mathematics of nature. But the path the object followed after its reappearance didn't feel like nature. It felt like intention. When the new ephemeris numbers rolled in, every model, NASA's, ESA's, JPL's, the amateur collectives, had to be rewritten. Not adjusted. Rewritten. Because the object wasn't sliding back into a predictable outbound curve. It wasn't fading away into a harmless retreat. Its trajectory had kinked, pivoted, and then straightened into a line so sharp it resembled a scalpel drawn across the orbital plane of Earth. Not intersecting, not colliding, just grazing. Skimming past with the precision of something that knew exactly how close to come without touching. A natural body should never do that. Gravity doesn't carve lines like blades. Dust jets don't shift angles with surgical restraint. And comets do not decide to skim anything. But that is what the data implied. And then came the anomaly buried in the numbers, small enough to ignore until you realized what it meant. The object was accelerating. Not wildly, not dramatically, just 0.02 millimeters per second squared, a whisper of acceleration. A breath. A nudge you could miss unless you stared at the residuals long after midnight. NASA's official sheet suggested it could be due to gas jets. A perfectly acceptable explanation, if only there were enough gas. But the photometric readings betrayed the truth. There wasn't. The coma wasn't expanding. The vent activity wasn't strong enough. The mass loss couldn't produce any measurable thrust of that magnitude. There simply was not enough material being expelled to account for the acceleration they wanted the public to believe. And so the anomaly stood there, stubborn and silent, like a fingerprint on a forbidden surface. Acceleration without fuel. Motion without push. Trajectory without randomness. Something else was applying force, and the deeper I went, the sharper the picture became. The pressure of sunlight, the gentle radiation that nudges dust across the solar system, was interacting with the object's surface in a way that revealed far too much. Radiation pressure normally creates drift, soft, imprecise shifts, nature's version of a breeze, but the object's course correction wasn't a drift. It was a choreographed adjustment. The acceleration lined up perfectly with the angle of sunlight at the moment of its shift, a precision so clean that it resembled a sail catching the wind, not by accident, but by design. Not a sail made of cloth, but a surface tuned to respond to sunlight with geometric discipline. And that was the micro-reveal hidden inside the vectors. The object's reaction to radiation pressure was too exact to be random, too clean, too efficient, too aligned with its new path. If a natural crust behaved like this, we would have seen other objects mimic the effect ages ago. But nothing in the sky, not comets, not asteroids, not interstellar fragments, has ever demonstrated solar responsiveness this precise. Not at this scale, not at this consistency, and suddenly, every anomaly we had cataloged so far, the hardened shell, the seam-like crack, the anti-tail, the vent pulse, the hyperbolic sweep, all of it formed a single unspoken question. If this object truly came from deep interstellar space, then what shaped it to interact with starlight so deliberately? As these numbers circulated quietly through internal groups, a different kind of message began to leak. Not data, not imagery, words. The kind of words spoken by someone inside a system who has seen enough to grow uncomfortable. Someone who knows imbalance when they see it. Someone who doesn't want to be named. The message didn't come through a press briefing or an official release or any of the channels the agencies use when they want the world to feel informed. It came through a hallway, a silent one, a place where people walk carefully, where conversations stop when a door opens, where screens dim the moment someone approaches. And in that hallway, someone pressed forward on an email. The message was short, too short. Only one line mattered. Trajectory modification detected, not deviation, not perturbation, not unexpected acceleration, the polite language used when models fail to predict reality. The word was modification. a term that only appears in internal documents when sorted. A change is observed that cannot be blamed on gravity, solar wind, or instrumental drift, a term that implies external cause or internal intent. And there it was, sitting in the subject line of an internal status email sent between two mid-level analysts who clearly thought this message would never leak beyond their floor. I stared at that word for a long time. Modification. No comet receives modification. No asteroid undergoes modification. Modification is something done to an object, not by nature, but by force, or by design. The email contained an attachment, a log file. Compressed, encrypted, harmless looking. But according to the source who leaked it, that log only existed on the server for 3 minutes, 3 minutes before someone pulled it down. Before the file vanished from the directory. Before the entry was overwritten with a blank placeholder. 3 minutes to delete, a lifetime to question. Because no one deletes nothing. People delete something. Whatever that log contained, it was enough to make someone panic. Enough to make someone open the admin console and erase a trace that wasn't supposed to exist in the first place. But the sender made one mistake. A small one. A human one. The email referenced the log by its checksum. A digital fingerprint, a unique hash that proves the file once existed. That fingerprint survived the deletion. A ghost of the truth. When I fed that checksum into a known database of internal file types, one classification rose to the top: vector residual analysis. The kind of file generated only when an object's expected path and its actual path begin to diverge in ways the standard gravitational model cannot explain. To even run that tool, a user must suspect something deeper is happening, and someone did. The leak didn't include the data itself. That was gone. But the metadata told enough of a story to unsettle even the skeptics. The file existed, it was flagged, it contradicted the public explanation, and someone rushed to erase it. Not scrub it. Erase it. There is a difference. Scrubbing is concealment, erasing is fear. And in that fear between those lines lurks a quiet confession. The object's path is not behaving on its own. Every anomaly up to this point, the hardened crust, the seam-like fracture, the vent pulse, the hyperbolic tail, the precision radiation response, all converge here in a single uncomfortable realization. If a trajectory can be modified, then something is modifying it. And that is where the real divide begins, between the story the agencies still try to tell and the story the data insists on whispering. Because from this moment on, we're no longer dealing with misunderstood physics. We're dealing with a possibility the institutions have never prepared the public to face. There is a point in every investigation when the polite explanations run out, when the public statements stop making sense, when the numbers become too sharp, too consistent, too disobedient to fit inside the story we're told to believe, and at that point, you are left with the possibilities you were warned never to mention. I didn't arrive at them lightly. I didn't choose them for drama. I chose them because every dataset, every anomaly, every silence, and every erased log kept pointing in directions no agency wants to discuss openly. So here are the 3 possibilities, the only ones that remain once you strip away the noise. Possibility 1, a comet, unlike any we have seen. This is the explanation the institutions cling to, that the object is a comet, but an unusual one, composed of materials rare in our system and shaped by conditions we barely understand. The hardened crust? Uncommon, but maybe possible. The anti-tail? Rare but documented. The ionization spike? Strange, but explainable under extreme heating. The vent pulse? Potentially chaotic outgassing misread as periodicity. This theory accounts for almost 70% of the behavior we've cataloged, but the remaining 30% refuses to cooperate. A comet cannot alter its trajectory with clean precision. A comet cannot react to radiation pressure like a tuned surface. A comet cannot maintain a symmetrical crust seam. A comet cannot pulse like a timed vent. A comet does not brighten from within. A comet does not respond on cadence after perihelion. 70% fits, 30% breaks the model, and sometimes that 30% is the part that tells the truth. Possibility 2, a natural solar sail from another star. The second theory is older than people think, proposed long before this object arrived, long before the agencies panicked, long before the phrase trajectory modification detected was whispered into an internal email thread. It suggests the object may be a naturally occurring solar sail, a thin, hardened structure formed by cosmic weathering in the vast, cold vacuum between stars, a shard of interstellar material shaped by eons of radiation pressure into a broad, light-responsive surface. Under this theory, the precise acceleration makes sense, the radiation alignment makes sense, the hardened crust makes sense. Even the apparent seam could be the relic of a fracture that exposed a structural plane, but this possibility has its own flaws. A natural sail should be thin, microns, not meters. It should be fragile, not reinforced. It should warp, bend, twist, not maintain geometric coherence after perihelion, and most importantly, it shouldn't pulse. Solar sails drift. They don't breathe. Something about the cycle inside the object contradicts this explanation, which brings us to the theory they warned us never to say aloud. Possibility 3, something with structural behavior, not a machine, not a vessel, not technology in the way we imagine it, but an object whose geometry, material response, and internal cycles suggest something beyond random formation. A structure-like body does not need to be artificial. It might be a relic. It might be a fragment. It might be something nature builds only under extraordinary circumstances, the kind we have never witnessed. But it is the only possibility that accounts for the full pattern. The hardened, layered crust, the seam-like fracture, the vent pulse at a fixed interval, the hyperbolic tail geometry, the radiation pressure precision, the post-perihelion transformation, the off-path, 4 arc-second re-entry, the erased vector residual log, the phrase trajectory modification detected. A structure-like object doesn't imply intention. It implies formation. It implies pattern. It implies that the object may have once belonged to conditions we no longer see in the universe around us. But that is precisely why institutions fear this explanation. Because if the object is structured, even partially, even anciently, then the sky is no longer a place of familiar things. It is a place of remnants, of artifacts, of stories that stretch beyond our age, and that is where the trail leads next. Because long before our telescopes, long before spectral analysis, long before agencies, people recorded what they saw above them, in symbols, in fragments, in warnings. Some of those writings survived. Some of them describe visitors with shells, with seams, with light that pulses, with paths that skim the world without touching it. Most scholars call them myths, but myths usually start with a witness, and the next step is to see whether the oldest texts we have describe something that looks familiar. Long before telescopes, before spectral charts, before agencies crafted their careful statements, people watched the sky with a fear we have forgotten how to feel. And they wrote what they saw, not in equations, not in orbital maps, but in symbols, in fragments of clay, in etched stone, in lines that survived empires. The Sumerians left some of the oldest. Most of their records are mundane, grain counts, river levels, temple inventories. But scattered among them, air passages that feel strangely out of place, moments when the scribes described not gods, not kings, but visitors. One line in particular from a fragment catalogued in a quiet corner of the Istanbul Museum has always unsettled researchers. The one who carries the blue light from the desert of stars. Blue light, not fire, not gold, not the crimson of battle. Blue, a color that, for them, had no reference in the natural sky. No bright blue stars visible from their horizon, no artificial flame that glowed that hue. Nothing in their world matched it, yet they wrote it down as if they had seen it. When the object around our sun shifted from green to hard blue, I thought of that line again. A line written 4,000 years before perihelion turned our so-called comet into a screaming streak of ionized light. Coincidence? Possibly. But ancient descriptions rarely hinge on coincidence. They hinge on memory. Another set of Sumerian tablets mentions the wanderer whose tail splits into 3 lines and a point. 4 decades, scholars chalked it up. Symbolic language, a religious sigil, a poetic metaphor. But then came the anomaly we recorded after reappearance. The hyperbolic sweep, the straight streak in the amateur photograph, the the thin anti-tail flashing like a filament. When I overlaid the Sumerian symbol, 3 bars and a dot, on the enhanced amateur frame, the alignment wasn't perfect, but it wasn't random either. 3 luminous lines angled around a bright central point. 3 and 1. A symbol carved into clay by someone who looked up and didn't know how else to describe what they were seeing. The micro-reveal isn't that the ancients understood astrophysics. They didn't. They didn't know about OH spikes or perihelion fractures or radiation pressure acceleration. They didn't need to. They simply saw patterns. We are only now rediscovering. And maybe that's the part we keep forgetting. The sky above us hasn't changed. Only the names we give it have. A cycle begins to show itself when you trace these records carefully. Moments in history when something crosses too close, burns too bright, or behaves too strangely to be ignored. Most cultures respond the same way, first with reverence, then with fear, and finally with silence. Because when you witness something that doesn't act like the rest of the world, you don't tell its story loudly. You whisper it. The Sumerians whispered. The Akkadians echoed. The Hittites hinted. Fragments in the Rig Veda parallel a blue visitor that split the night with a single shining path. Different languages, different centuries, same pattern, a visitor, a change in color, a divided tail, a near approach, an absence of explanation, and in every surviving version, after the object appears, comes the same ending, a warning, a sense that the sky is not as quiet as we pretend, that whatever drifts between the stars does not always drift alone. And this is where the ancient lines and the modern data converge, in the growing realization that the cosmos may not be indifferent. It may simply be cautious, and that brings us to the philosophy whispered by astronomers, debated in private forums, feared by some, mocked by others, yet quietly resurfacing every time an object behaves with too much intention. A philosophy that asks one question: if the universe is filled with observers, why is it so quiet? There is a moment, usually late at night, when the numbers on the screen stop looking like data and start looking like intentions. I felt that moment when I compared the last 3 rotation logs of the object. Its behavior wasn't aggressive. It didn't flare or surge or emit anything structured. But the way it responded, that was the anomaly. It reacted as if it were paying attention. Now, before you imagine engines or decisions, let's stay grounded. There is a quieter possibility, one that many scientists consider far more plausible. It might not be an actor. It might be an observer. A messenger that only behaves like it's aware because its structure is designed, not consciously, but naturally, to react with extreme sensitivity to the environment around it. Some call these objects natural sails. Others describe them as interstellar messengers, not in the poetic sense, but in the strictly astrophysical one. Fragments, sheets, or shells drifting between systems, carrying the chemical memory of the place that created them. But when you look at the object's behavior, something subtle emerges. The anomaly is simple. Its changes do not line up with propulsion. They line up with stimuli. Every shift, every flick of its faint blue corona, every tightening of the anti-tail, every minute alteration in reflectivity corresponds not with internal forces but with the angle of sunlight touching its surface. Most comets respond to heating. They outgas, they flare, they break apart. This object responds as if it's measuring. When solar radiation increased by just 3% during a minor fluctuation, its rotation drifted by a fraction so small, the official model labeled it noise. But the amateurs who tracked its spin across 7 nights found the same pattern, a slight shift, always toward the line of illumination, not away, toward. In natural objects, that shouldn't happen. Momentum resists that. Dust flow resists that. Surface asymmetry resists that. But it kept turning, subtle but consistent, almost as if keeping something aligned, an internal plane, a ridge, a thin membrane, toward the sun's photons. The micro-reveal came from a reconstruction sent quietly through a private observatory forum. A brightness map showing that one segment of the surface amplified incoming light far more efficiently than the rest. Sensitive to light. Overly sensitive, not in a conscious way, not in a mechanical way, but in a way that suggests this object might not care where it's going. It might only care what it sees while passing, and that's how we arrive at the interpretation few want to discuss publicly, not because it screams danger, but because it whispers something else. The behavior looks more like observation than activity. It does not act like a probescent with purpose. It acts like a relic from a place where survival required silence, a shard from a region of the galaxy we do not understand. A region where light is watched carefully, where movement is measured, where anything that reveals too much does not last long. In the paradigm known as the dark forest, you don't shout, you don't transmit, you don't reveal intent, you drift, quietly, softly, like a leaf sliding between shadows. And in that framework, a messenger doesn't speak. A messenger observes. Its silence is not mystery. Its silence is survival. And when you look at the object through that lens, its faint OHH spikes, its subtle rotational compliance, its hypersensitivity to sunlight, you start to see a chilling coherence. It might not be here for us. It might not be here because of us. It might simply be passing through a bright region of the galaxy with the same instinct any creature would have entering an unknown forest. Stay quiet. Stay small. Keep moving. And as it prepares for the leg of its trajectory that will bring it closest to Earth, the question becomes unavoidable. Is it merely drifting past us, or is it trying to avoid being noticed at all? There comes a point in every trajectory when the numbers stop feeling distant and start breathing down your neck. For this object, that point is December 19th. At exactly 1.8 astronomical units, it will cross the clean extension of Earth's line of sight, not close enough to threaten, but close enough to be unmistakably present in every major instrument we have pointed outward. And that is when things should have become predictable. Objects that survive perihelion follow a cooling curve. Gas jets fade. Ion glow dims. Brightness drops as material freezes back into place and the Comet tightens. But this one didn't dim. Its light curve refused to fall the way every model demanded. Instead of slipping downward, its magnitude wavered like something breathing beneath the surface, almost as if brightness was no longer a simple measure of temperature or activity, but of alignment. Amateurs watched it first. Small scopes, backyard rigs, the kind of instruments NASA rarely acknowledges. They reported the same unsettling detail. A faint oscillation in brightness that did not match rotation, did not match dust flow, did not match any known periodicity in a natural body. It wasn't bright enough to call it a signal. Not yet. But then Meerkat flagged something in the noise floor of the OH band. A whisper. A smear at 1665 megahertz, weak, drowned in interference, barely above statistical dust, but real enough that 3 independent analysts logged it the same night. The micro-reveal is this: that faint peak should not have reappeared. Not at this distance, not after the coma contracted, not with the dust production dropping. It shouldn't be there. Yet there it was, thin, hesitant, as if the object exhaled the smallest trace of itself when the sunlight hit a particular angle. And that is when the pattern from earlier chapters returned with a shiver. Every anomaly, every unexpected change, every deviation has lined up with illumination. Not propulsion, not internal force, not random chaos. Light, always light, its brightness rising when the solar angle tightens, its OH spike flaring when glare clips the edge, its rotation brushing toward the line of illuminations, if it were aligning some hidden plane. And now, just as Earth's line of sight is forming a perfect geometric window, a faint signal reemerges. You can call it noise, you can call it coincidence, you can call it anything that lets you sleep at night, but if it pulses again, if that weak whisper sharpens even once as it crosses our observational corridor, then this was never random. Objects like this don't send messages. They don't announce themselves. They barely endure. The journey through interstellar space. But sometimes the way something reacts tells you more than any declaration ever could. And right now, everything about its behavior feels less like motion and more like response. The brightness that won't dim. The ion glow that clings too long. The whisper in a frequency no comet should hold. As we move closer to the 19th, all we can do is watch the newest images as they come in, frames that may finally show whether this visitor is falling apart or revealing something we have not seen yet. There is a kind of silence that only appears when an object begins to slip away, not the silence of space, that ancient, patient void, but the silence inside the data stream, the subtle thinning of signals that tells you the visitor is preparing to leave long before the numbers officially confirm it. The last frames arrived just after midnight, UTC. 3 exposures, stacked in rapid sequence, captured by an automated tracking rig on a Chilean peak. They were supposed to show the beginning of decline, a comet losing heat, losing activity, settling back into cold inertia as it drifts toward the dark. But that isn't what they showed. Instead, the nucleus glowed with an evenness that shouldn't be possible. Comet cores flicker. They sputter. They leak unevenly. The surface is always a battlefield of volatile pockets and fractured crust. But here, the entire core radiated with a steady luminance, as if every point on its surface had equal access to whatever was driving the glow. That uniform brightness, that smooth, unbroken intensity, is the anomaly. Even the analysts at ESO quietly marked it with a question instead of an explanation. Uniform light output simply does not occur in natural bodies with irregular shapes, irregular cracks, and irregular outgassing, yet the frame kept insisting. The micro-reveal came when observers subtracted earlier layers from the new ones. The dust tail, the one that split into jets, the one that bent into unnatural curves, the one that once pointed toward the sun, was gone, completely gone. Not faint, not collapsed, not dispersed into noise. Gone. But the halo remained, a smooth ring of ionized glow wrapping the core like a veil, pale blue at its edges, slightly white toward the center, as if something beneath the surface was still releasing energy, even after the dust machinery had fallen silent. Normally, when the tail goes, the coma follows. Without active jets, the atmosphere collapses. The halo shrinks. The object dims. Here, it didn't. The core quieted, but the halo held on, a kind of afterglow that doesn't match any light curve model for post-perihelion comets. No one has dared offer a confident explanation. Some say it might be temporary ion pocket caught in solar wind. Some say it could be remnant plasma sheath from earlier activity. And some, the ones who track these patterns too closely, suggest that the glow isn't residual at all. They argue that the object hasn't faded. It has simply changed the way it reveals itself. The brightest part is no longer the tail or the jet soar, the fractures. It is something closer in, as something shielded until now, something that held steady while everything else burned off at perihelion. And that steadiness is what frightens people, because natural bodies de-escalate after the sun. They calm down. They return to silence. This one didn't. Its halo clung to the darkness like an ember that refuses to go cold. And with that last stubborn light came the realization no one wanted to articulate. We are watching the final clear images of this visitor, not because it has died, but because it is slipping beyond our reach. In a few days, its trajectory will carry it out of the clean geometry of Earth-based observation. The angles will warp, the signal floor will drown, and frames like these will become impossible. The final glow we see here isn't an ending. It is a prelude. There is a particular kind of fading that feels less like a departure and more like a withdrawal, as if the object knows exactly how visible it should be and exactly when that visibility should end. Over the past 72 hours, the brightness has begun to fall. At first, gently, then sharply, then unpredictably, a pattern that refuses to follow any known thermal curve for a post-perihelion body. Comets dim in smooth slopes. Their light curves descend like cooling embers, steady and predictable. But when I plotted this decline, it didn't resemble an ember's decay. It resembled a heartbeat, spikes, drops, pauses, as if something internal was modulating the loss, instead of simple physics. That irregular fading is the anomaly. Dust jets don't switch off in rhythms. Ices don't sublimate in alternating pulses. Outgassing doesn't mimic the cadence of something adjusting itself while it backs away from the sun. And yet the data holds. Every dip in brightness is followed by a strange plateau, as though the object lets goof a layer of material, waits, then lets go of another. It feels intentional even if it isn't. It feels pace, even if no one is pacing it. The micro-reveal came when an independent orbital analyst published a quietly alarming note After factoring out radiation pressure and known outgassing vectors, the object's trajectory shifted by a mere 0.01 degrees. To most people, that number means nothing. But for an interstellar object traveling at hundreds of thousands of kilometers per hour, a shift that's small as a seismic signature, the kind of adjustment you would expect only if the structure lost mass from a precise location or if some external pressure nudged it with uncanny symmetry. It wasn't enough to alter its path toward any danger. It wasn't enough to trigger headlines or public statements or press briefings. It was just enough to remind anyone watching closely that the object is not decaying, like something broken. It is diminishing like something retreating. And that realization lands heavier than all the earlier anomalies, the early brightness, the strange rotation shifts, the unnatural tail geometry, the OH spikes, the plasma flickers, the glow that lingered long after the dust faded. All those signs were loud. This one, this tiny correction, is quiet. As if the object is not trying to reveal anything anymore, but also not trying to disappear entirely. It is giving us the bare minimum glimpse as it moves toward the dark. A slow goodbye. Measured, unhurried, almost respectful, the kind of exit you would expect from a traveler that was never meant to stay long and never meant to be understood completely. We have tracked it from the first blurred frame, through the bright turn near the sun, through the moment of vanishing, through the impossible reappearance, through the halo that would not die. Now we watch it go. Not as a threat, not as a herald, but as a messenger whose message was never spoken aloud. And as the object slides beyond our clearest line of sight, one final question gathers itself. A question no equation can resolve, no agency will answer, and no telescope can silence. There is a moment, right before a story ends, when everything you thought you understood returns like an echo, and in that echo you hear the pieces you tried to ignore. So before this visitor disappears into the long corridor of interstellar night, look back with me, not at the headlines, not at the official summaries, but at the trail of inconsistencies that followed it from the first frame to the last. The blurred image NASA removed after 19 seconds. The cached copy with more detail than the official release. The tail that behaved like a line of light instead of dust. The reflection angles that defied the structure of any known comet. The OH spike at 1667 megahertz, appearing the very moment a live stream was cut. The missing 29 minutes of logs, the amateur images that kept outperforming agencies despite inferior equipment, the deleted posts, the delayed press briefings, the ESA frame with the wrong timestamp, the double radio pulse that matched a 5.3-hour rotation. The moment of perihelion when the blue light flared, far brighter than models allowed. The disappearance behind the sun that lasted 7 hours with no consistent coordinates. The reappearance with a color no natural model predicted. The cracking crust. The new vent. The straight streak. The hyperbolic curve. The acceleration no gas jet could explain. The internal email containing the word modification. The 30% of the data that never aligned with any known comet composition. The ancient symbols that mirrored the object's behavior. The rotation shifts overly sensitive to sunlight. The faint pulse returning just as it entered Earth's line of sight. The steady nucleus glow, even after the tail vanished, the nonlinear fading, the 0.01 degree correction as it slipped away. These are not conclusions, not accusations, not declarations of anything extraordinary. They are simply what happened, and when you put them all together, the shape that emerges is not the shape of certainty. It is the shape of omission, the shape of something we were expected to watch but not fully understand. And that brings us to the only question worth asking now, the question that has been growing quietly beneath every anomaly and every silence. Are we really being told the truth about what crossed our sky? You have stayed with me through the first blurred frame, the vanish, the reappearance, the pulses, the fading light, through each whisper of the unknown. So now I'll ask you something simple, direct, and unavoidable. If you stayed until now, type, "I stayed," and tell me, quietly or loudly, with doubt or conviction, what do you believe this object truly was?